Hi everyone, welcome to my YouTube channel TechDataEngineer. So today we will see one of the important topic UDF in pyspark. Okay, why we are using UDF, what is the benefit of UDF, and in which scenario we are using UDF. Okay, so UDF in pyspark, basically this is nothing but a function. Okay, so it's like a user defined function. So in pyspark we have two type of function. One is inbuilt function and one is the user defined function. So the function which is not there, that is already not there in the pyspark, and there are some complex transformation. Because of that, if we are defining our own function for some specific work, that is called user defined function basically. Okay, so in PySpark, we have to in normal Python. What we are doing, we are just defining the function with the def keyword. Okay, def and then function name and whatever the body we were defining, and then calling the function. Similar way, we have to write the function here also, but for calling the function, we have to first register and then call on top of the some feature like in say column name. Okay, so UDF stand for user defined functions. It allow you to define custom functions that can be applied on your Spark data frame columns. Okay, using PySpark SQL function. So under PySpark we have SQL functions with column or select method, so we can import that and then we can use that. Okay, so that is that is basically UDF. Okay, so then the questions comes again, why to use UDF. Okay, so why we are using UDF? So basically first reason is the custom logic. Okay, so UDF always allow you to write your own custom logic. Okay, if that is not available in by default your built-in PySpark function, so you can use your custom you can say function, and this gives the flexibility to use that also. Okay, means it gives flexibility when we wanted to transform some data, or we can say reuse again, then it will give. So for custom logic you can write the UDF. If there are some transformation which is very complex, which I already mentioned, if some complex transformation, right, like something is not there in your build function, so for complex transformations you can write like can say you can write your own UDF. If this complex transformation means involves in multiple steps, or you can say non-standard informations, so you can use your UDF logic and then encapsulate in your functions, so that way you can do that. Other is Python compatibility. So PySpark UDF can be written in Python, which makes it easier, you can say, to integrate with the existing Python code. If you have already existing Python code, then you can write the UDF in one module and then you can integrate directly. So these are the, you can say, benefits why we are using UDF. One would be the custom logic, other would be the complex transformation, and other would be the Python compatibility. So next come forward, like what is the benefits of using UDF? So benefits use, it's like a reusability. We can reuse once we'll define the UDF. Okay, once we'll define the UDF can be used across different data frame operation. uh, so it will basically give the code reusability and reduce you can say redundancy also. So if we have multiple module defined under a single repository, then what we can do, we will define functions UDF under a single functions, and then we can use it also. Then integrations, so UDF integrate seamlessly with PySpark data frame API. We have already the data frame API, we can just build our own this one UDF, and then we can apply. Okay, and then we can apply alongside with the you can say built-in functions also. Okay, so these are the benefits we have. Okay, so these two are benefits, reusability and integrations. Okay, then next come to some example. We will see some example. So these are the steps. From pyspark.sql we are importing spark session, then under the sql.functions we are importing the UDF, and then what are the data type if you wanted integer, string type or some different, we can import that also. So that is simple data we have taken 110, 230, 235 and 350. So this is the sample data. We are creating the data df equals to spark to create data frame data, and then schema is like id and age. So these are the two column name, that is schema. We have already defined id and age. So we are creating the data frame. Okay, so the data frame is like id and age. So then what we are doing, we are just writing a UDF. So the UDF basically what it will do, like it will based on the age category, it will segregate the data, you can say. So what we have done, we have defined a function using def keyword, how we are defining in the Python. So def age group, we are passing a age as an argument. So if age is less than 30, then we are returning as a young, else age is less than 50, then returning middle age, and then else the third condition, return senior. If these two are not matching, then well, we will return as a senior. Okay, now let's come to registering. So age group UDF, we have taken a name as age group UDF, where UDF and then age group we are defining. This is the function name what we are defining here, and then what is the return type of the string type. Then what we will with the help of with function with column, we will define a new column called age group, where we will age group UDF we will pass under that that column age. So what it will do, it will basically take that each column, and based on that it will create a new column age group, and it will write like a young, middle, senior, similar to that. Okay, and then we will we finally what we will do, we will write with the help of df dot show, and we will get the three column like id, age, and then with column age group. So this three column, one have the id, one have the age, and other have their category. It's like a young, middle age or senior. So this is a simple example why we are using UDF, what is the use of that, and how can we reuse under the multiple, you can say, how can we integrate with the existing Python functions also. Okay, so this is the benefit if you using UDF. Okay, so you can define your own custom logic function. So in real world, if you'll work on the real world scenario, so you have to write your own UDF, because these inbuilt functions are not sufficient to do some transformations and all. If complex transformations are there, so that time you have to define your own UDF, and then you can work with that. Okay, thank you, thanks for watching.